Hi. Okay, so I could think of no better way to do this, except for just recording myself. So I'm just gonna record like I'm here, and we're gonna just go through everything as though I were in the classroom. So you should have already cut this out and glued it into your math notebook. So this top part, I don't care if you put it on 1 page or 2 pages, it's just however you wanna do it, I don't care. All of the different properties of the order of operations are here. So like, in other words, the properties of operations like commutative property of addition, of multiplication, associative property of addition and multiplication, and then distributive property. Gives you the definition, gives you an example, and then using that example, you're gonna come down here and you're gonna label these. So you probably already did that. At the end of this video, I'll go back over these just so you make sure that you have the right answers in. Okay, so you should have already done pages 229 to 231. I'm just gonna walk through some of this with you. I'm not gonna put all of it on the board. Well, I might actually. So really what you're doing, in Step It Out, it says substitute the given value into both expressions and determine if the expressions have the same value. So you're really just working with two different expressions that you're wondering if they're equal. So you're gonna plug in the 6 every time you see X. And then once you get down to the bottom, you're gonna decide if they actually do have the same value. So the very first one that we're gonna do is x squared minus 5x. And in this equation, x is equal to 6. Then we're gonna do x times the difference of x minus 5. So if you look, this is the distributive property, and a little hint here real quick, x times x is just x squared. X times negative 5 is just negative 5x. So we already know that these are going to be equivalent whenever you use the distributive property. That's the good thing about knowing properties, is that you can already see that it's going to be equivalent, but we're going to work it one step at a time, which is step it out. So whenever you plug it in, it says to substitute, so you're going to have 6 squared minus 5 times 6. Over here, we're going to substitute, and you're going to have 6 times 6 minus 5. When we do that, it says evaluate the exponent, so 6 squared is 36, minus 5 times 6. This one, it says to subtract, so we're going to do 6 times 1. When we multiply, we're going to do 36 minus 30. 6 times 1 is 6. 36 minus 30 is 6. They are equivalent. We come up with the exact same answer down at the bottom. There's one less step on the one on the right than there is on the left. There's an additional step. So you would circle the expressions do have the same value when x equals 6. Letter B is talking about a formula for a hexagon, and is actually talking about the formula for the perimeter of a hexagon. So when we find the perimeter of a hexagon, we can use this formula every single time. The formula is 4 parentheses x minus 2, and actually we're trying to decide if we can use this formula. So there's our first one, there's our first part of it, and then the second part of the problem is trying to decide, are these two things equal? Could we actually use this formula? So we see that we're going to substitute in every time we see s. We're going to substitute in this case, 8. So we would have 4 times 8 divided by 2 plus 2 times 8, or we would have 4 times 8. So then once we get everything substituted, we're going to go ahead and divide. 8 divided by 2 is 4, so we're going to rewrite this, and then we'll rewrite exactly what we have here. Oops, I just closed my page. That's not very helpful. All right, so then it says we're going to multiply this one over here. So 4 times 8 is 32. Now, like I said on the last one, you had a couple of extra steps. You have a couple of extra steps on this one. 16 plus 16. This one's still just 32. This one is still 32. So that means that they are actually both equivalent whenever they have the same value, whenever they have the value of s equals 8. So if we changed the value, so for example, if the hexagon had sides of 2 instead of 8, would it still be the same? So if we plugged in 2 here, if we plugged in 2 here, would it still be the same? Would they still be equivalent? Yes, because that's the thing with a formula, is that it doesn't matter what we plug in, as long as we do the formula the exact same way and we plug in the variable and we know what the variable is equal to, like in this case, S was equal to 8. But it doesn't matter if S was equal to 2 or 10 or 50. It doesn't really matter, because when we plug it in, it should work out every single time. Down at the very bottom, it says, do the expressions 4S and 5S have the same value when S equals 0? So, what do you think? If this is true, that we can plug in any value whatsoever, it doesn't really matter. There's one thing that doesn't work, and that would be 0. Here's why. If we had 4S and 5S, oh, actually I'm lying. Hold on a second. Would they be the same? Yeah, they would. I didn't mean to lie to you, but I did. 5S and 4S, if S is 0, then they're gonna have exactly the same answer, because anything times 0 is 0. So it doesn't really matter what the formula is here, as long as S is equal to 0, it's always gonna be 0. We could put in, this could be 16S, and then in place of the S, we could put in a 0, so 16 times 0 is 0. I'm losing my brain when it comes to zeros today. All right, turn the page. We are on page 230. 230, you'll recognize that chart is exactly the one that you just cut out. At the very top, it says equivalent expressions, and it just tells you a definition for it. They're just expressions that have the same value for all possible values of the variable. So of course you can't check every single one of them. It could be negative infinity all the way to positive infinity. So every single number, or even rational number, even any decimal, any fraction, everything could fit in there. And you can't check all of those values, but you can check two different sets of pieces of information, like what we did on the first part on page 229. And you can see if those two equations are equal to each other. So the property that actually supports that idea, there are 5 different properties that support that idea. So down at the bottom, identify the properties used to determine if the expressions are equivalent. So if we look down at the very first one, it says 4 times the sum of A plus 2B plus 4A, and then you're also comparing it to 8 times the sum of A plus B. So if you look, what you're looking for here on letter A is you're looking for how did it change from that first line to the second line? So if you notice, it spread out that 8 times A plus B. So in other words, now it's 4A plus 8B plus 4A. So 4A plus 4A would be 8A, because if there's 4 A's and you have another set of 4 A's, now you have 8 total A's. So that's the exact same thing as distributing that 8 times A plus B. Let me put this up on the board so you can see it. So on this one, we're trying to decide if these two equations are equal to one another, or actually these two expressions are equal to one another. So we're trying to decide if that is equal to, we don't know, the distributive property is going to be used here. I really hope this isn't going off the screen. It might be, I guess we'll see. So you can, you're looking at what's different. So actually what's different here is they said 4A plus 8B plus 4A. So these two, 4A and 4A, is the same thing as 8A, and there's your 8B. There's your 8B right there. So what they're doing is, looking down through those properties, all they did on that very first one is they used the distributive property. They kind of undistributed it. On the next line, if you look, they changed where the 4A plus 8B plus 4A is. They moved that 4A so that they're together. That's the associative, no, I'm sorry. That's a commutative property. They moved them. They moved one to another, but it doesn't change the value of it. They changed its place. And then on the third line down, it says, the parentheses say 4 plus 4, A plus 8B. So they've taken that 4A, so it was 4A plus 4A plus 8B. I really hope you can see this. And they've taken this and put them right here. So then they have this 4 plus 4 is 8. Well, that makes sense because 4a plus 4a is 8a. 4 plus 4 is 8a plus 8b. So they're proving we're going to add everything inside the parentheses. 8a plus 8b is equal to 8 times a plus b. So that would be the distributive property on the very, very bottom. So it is equivalent to 8 times the sum of a plus b. Letter B. Letter B is just talking about kind of a similar situation. You are looking at the distributive property where you're going to say, we're going to set this equal to 3xy. I don't understand what they're asking us to do here. Let's see. Nope, not a clue. I have no idea what they're asking us to do here. Okay, we're going to end this one on page 230. I have no idea what they're trying to ask us to do. If you look over on page 231, let me grab my teacher manual. Hang on real quick. So we'll look at that one on page 230. And maybe once I see the answer, it'll make me understand what they're actually trying to ask us to do. So, oh, they're doing it wrong. That's what makes sense. Okay, so they're trying to say 8xy plus 5xy would be the same thing. Let me erase this real quick. The reason I don't think it made sense to me is because they're not equal. We're going to find that out at the bottom, but they are not equivalent to each other. So we have 8xy plus 5xy. And we're trying to decide, are they equivalent to 3xy? I think. Is that what it's asking? Yes. So then what they did was they took this and they broke it apart using the distributive property. So they said 8 plus 5 times xy, is it equal to 3xy? Well, we know that it's not because 8 plus 5 is 13xy, and that's not the same thing as 3xy. So they are not equal to each other. And you use the equal sign with a slash through it. This is not a very good one, but you use the whole equal sign with a slash through it, and that shows that they're not equivalent to each other. All right, going down on page 231, if you look at the very first one, it's talking about, we're trying to actually figure out the perimeter of a triangle given the sides of s plus 1 plus s plus 2. So we would say, if you look at that very first line, we're trying to figure out which property of addition it is. It's either commutative or associative. You only have two choices. So if you're looking at what's different, they are associating, they're deciding to add the s plus the s instead of adding that s plus 1. So the parentheses change places. The numbers didn't change any order. The numbers are in the same order. The parentheses just change places. The next line down is commutative because if you look at it, the actual numbers changed, the numbers in the letters change places. So the s plus s stays the same, plus, and then if you look from that associative property of addition line, that second line, the s plus 2 went down to the left-hand side just a little bit, plus 1. So they change places. So it's the commutative property of addition. Going down from there, they decided to add all of those s's together. So s plus 2 plus 1. So that would be 3. So that's the associative property of addition. And then going down to the very bottom, that very bottom line should be distributive property because they're going to take the 1 plus the 1 plus the 1, which would be 3. They're going to plug in their s because that's how many s's there are. There's 3 s's. Plus 2 plus 1. Down at the very bottom, you should have equals 3s plus 3. Add those together. And then whenever you look at it, you would say, okay, it would be much easier to remember the formula 3s plus 3 rather than s plus 1 plus s plus 2. So if you look, really what we're doing is we're just gathering like terms. So we're putting everything together that's the same. So s plus 1 plus s plus 2. So everything that is the same, in other words, everything that is a constant, remember that that's just the numbers that don't change, so positive 1, positive 2, and then everything that's a variable, and it has to be the exact same variable, so those are all s's. If they were like, if one of them was like s squared, that wouldn't be the same variable. So we are going to combine everything that's the same. We have 1, 2, 3 s's. And then we have, so we've taken care of these. The only thing we have left is the 1 and the 2. They're both positive, so there's our answer. To me, that's an easier way to do it whenever you're gathering like terms. That's actually coming next in the next lesson. So this is just kind of one little step ahead. Going on down, number 4. It says, are these expressions equivalent? So they are like terms because 6w plus 3z plus 4w plus 7z, the terms 6w and 4w are like terms. So this is kind of the next little step of it. So we would combine that 6w and the 4w, and the terms 3z and 7z are also like terms. So we would add all of those together. We're going to move them around where we have to using the commutative property of addition. And then once we do that, we're going to actually take and distribute that. So we have, and I know this seems very tedious whenever we're looking at all of these properties. It seems kind of silly to do it this way because you can do it this way. You can do it probably more quickly in your head where you're gathering like terms. But the reason you're able to do that is because these properties of math exist. That's important to understand because as you get further in math, especially in geometry, you have to do what's called proofs. You have to prove using these properties why certain shapes are related to other shapes. And you can't take for granted anything in geometry. I like geometry, but it's a little frustrating because you have to prove everything. All right, so this one is 6w plus 3z, I can't see this, plus 4w plus 7z. And so really, I'm going to put lines through here so I don't think they're 2's. Really what they're actually doing is they're just trying to move some stuff around to make it a little easier. So once we commute these, we have the 6w and the 4w together, and we have the 3z and the 7z together as well. So we've done the commutative property of addition. Now we're going to take and we're going to distribute these. So 6 plus 4 times w plus 3 plus 7 times z. When we do that, that's the distributive property. We're going to actually add inside the parentheses. We're going to say 10w plus 10z. We've actually added them. And so then whenever we look at the distributive property, we're trying to decide if it is equal to, if both expressions are equal to each other. So we're going to use the distributive property, and we're going to say 10 times w plus z, because that's exactly the same thing. They're both 10s and they're both being multiplied. So the w is being multiplied by the 10 and the z is being multiplied by the 10. So the coefficient for both of those, the w and the z, is 10. When we look at it, we say they are not equivalent because 8w plus z was what they were trying to decide if they were equivalent to each other, and they are not. So they're not equivalent to each other. Okay, this is a lot. So down at the bottom, for the very first one, it says rewrite the expression to determine whether the expressions are equivalent. So on that very first one, 8x plus 4y. So this is on check understanding. We're down at the very bottom on number 1. You're rewriting that first expression, and you're going to say 8x plus 4y. And we're going to rewrite it to be, I'm going to pull out a common factor. So I'm going to look for the greatest common factor in this, and I'm going to say, okay, both of these numbers, 4 is a factor of both of them. So I'm going to pull out a 4 out of both of them. So 8 divided by 4 is just 2, but I still have an x. And 4 divided by 4 is 1, but remember that we don't have to show the coefficient of 1, so I just have a y. Now, I can double check my work just to see if I'm correct before I go any further. Okay, 4 times 2x would be 8x. 4 times y would be 4y. Is that what I had to begin with here? Yes. So actually they are, these two are equivalent to each other, but that's not actually the question. The question is it equivalent to 4 times 2x plus 1? That's what we're trying to decide. And it is not, because what it is equivalent to is this one. These are not the same thing. 1 is not the same thing as y, because y could be anything. We don't know what it is. but 1 is always 1, it's constant. So they are not equivalent to each other. The last one, number 2, says 3 times k plus 3. So we're looking at 3 times the sum of k plus 3. And we're trying to decide, is it equivalent to 3k plus 9? So we're looking and we're going to say, is it equivalent to 3k plus 9? Well, actually, whenever we do the distributive property, we would say that's 3 times k is 3k. 3 times positive 3 is positive 9. And that is equal to 3k plus 9. So yes, it is equivalent. Okay. Your homework, and this is actually due at the beginning of class on Thursday, so you have today and tomorrow to work on this. Your homework is, let me pull my phone so we can go look at it together. Okay, your homework is, oh rats, I can't find it. Nope, that's not it. Aha, there we go. You would think I don't know how to work a phone. Okay, your homework is, IXLs are due tomorrow, and then you have page 232, numbers 3 through 13, and 14 through 32 evens, and they're due at the beginning of class on Thursday. So if you look at Wednesday's assignment, it's the exact same thing. On Thursday, you have a little bit of a practice that you're going to do on formative. It hasn't opened up yet. And then on Friday, you'll have a Delta Math. It has not opened up yet. So that equivalent algebraic expressions practice that's on formative is actually due on Friday. So you'll have Thursday and Friday to work on that. All right, last thing that we're going to do is, and I don't have the answers to this, so we're going to have to go over this one together. But last thing that we're going to do is go over this one. When we look at that very first one, 7m times 4y is equal to 4y times 7m. They've just changed places. It's multiplication, so it's the commutative property of multiplication. The next one, 3 times the sum of 4a plus 7 is equal to 12a plus 21. All we've done is we've distributed that. We've distributed the 3 to the 4a to make a 12a, because 3 times 4a is 12a. And we've distributed the 3 times the positive 7 to be positive 21. So 12a plus 21 is equivalent to 3 times the sum of 4a plus 7. That's the distributive property. The next one, everything is in the same order. If you look at it closely, everything's in the same order. We've just moved the parentheses, and it's all addition or subtraction, which is just adding a negative. So it really is all addition. And so that means that we've just changed the parentheses, not the order. It's the associative property of addition. The fourth one down, 3a plus 4b is equal to 4b plus 3a. We've just changed where they're at. So that's the commutative property of addition, commutative property of addition. And finally, the last one, we didn't change the order of anything. Oh, yes, we did. We did change the order. Oh, I did not mean to do that, but that's okay. We changed the order of this, so multiplication. It is the commutative property of multiplication, but it accidentally is also the associative property of multiplication. So it's really both. It's really both the commutative and the associative property of multiplication. Okay, I think that is it. Hopefully this makes sense.